Okay, that's my upper left-hand corner, yes. So put your name in the upper left-hand corner, and we're going to give it a title. The first one we're going to start with today is called Creating Congruent Segments. Okay, and I'm going to put a number 1 in the upper right-hand corner. That's what I want in the upper right-hand corner. Creating congruent segments. Everything that we are going to create in this series on constructions is going to be done with a ruler, compass, and pencil. So having your pencil sharp is going to be important, and making sure that you have a ruler and compass is also important. So here we go. You're going to start by creating a line segment. The length doesn't matter, and I'm just going to put it not necessarily all the way near the bottom, but about that far away. So I'm just going to draw a line segment, like so. Not incredibly long. And I'm going to put points at both ends, and I'm going to call it AB. So this is segment AB. And this is the segment that we are going to copy using our compass and ruler. So this is pretty easy so far. You're just drawing a line segment. It's a segment because there are points on both ends. Okay, so both here and here. If it was a line, the line would extend through the point towards the edge of the paper, and the same thing over here. If it was a ray, it'd only extend through one point, and the other point would be a termination, or it means that's where it would stop. But this is a segment because it terminates on both ends. Now, to copy this segment, we need to have a line to copy it onto. So I'm going to use my ruler, and I'm going to go ahead and just draw a line all the way across the paper, like so.
Halfway up?
Yeah, about halfway up. And on that line, I'm going to put the point R. Okay, notice that I offset it a little bit.
Is that all the way across the paper?
Almost. Almost. Good question. Okay. At this point, there's very little I can do with the ruler, so now it's compass work. Compasses are used to both draw arcs and to measure distances. All right, that's the whole point. But they don't use the numbers to measure distances. What we use is this slider, okay, right here. So what I am going to do is I'm going to place my compass such that when I slide it up, it's going to slide, the one end here is going to slide over A, and I'm going to adjust the slider portion so that one of the two holes is over B. It's important that I remember which one. For my purposes, I'm going to get it close right now so that the end one is near B and the beginning is near A. And I'm going to slide it up and adjust it. You should do the same. So that the end is over A and this end is over B. Okay. To make sure that it's in the right spot, oftentimes you'll see students of geometry draw a little arc, okay, just to make sure that the measurement is right on. So what I'm going to do is where my point B is, I have my pen here, I'm just going to go ahead and swing an arc through that point. Okay. Now I'm going to carefully take my compass away without moving the slider. That's the important part. If you move the slider, then you have to do this whole thing over again. Okay, so I'm just going to just kind of pull it off to the side. And it looks like my measurement was right on. It went right through B, and that's what I wanted. Okay, what I've just done is I've used my compass to measure the distance without using numbers. So I'm going to then take my compass and slide it over point R, like so. Put my finger down to clamp it in place. And using the same hole that I used to draw the arc through B, I'm going to draw an arc that intersects that line at the top of the paper. I take it away. I'm done with my compass. The last thing I need to do now is I need to label this intersection point, and I'm going to call it Y. The naming convention doesn't really matter so much. You could have done D, E, B, C. You could have done a variety of different letters. You could have done symbols. Okay, so I'm just kind of I'm using these at random. There's no rhyme or reason to my naming scheme. But what I've done is I've now created line segment RY. And they are exactly the same length. So I can say that RY is congruent to AB. And notice the way I named them. Left to right, RY, AB. If I was to name them the other way, it would be AR, BA. Or, excuse me, YR, BA. That's the end of that construction. Anyone miss a step somewhere along the way that they'd like me to go back through and just talk about? Okay? Where'd you miss?
The line on B, the arc.
Okay? So to get that arc on B, I just put the compass so that I can see point A here. And I clamp it down with my finger. And I use the slider to line up with B. And I draw that arc. That's it. Then I transfer that up to the other line. And I drew the same distance arc there. And that's how I get congruent segments. Any other questions? You guys have congruent segments?
No. Just get it on because I can't see.
Okay. Hey, Christine, you want to open up the windows?
Oh my, it's steamy in here.
Not open up the windows in the sense of that. Open up the blinds so that we can actually get some light in here. That's fine.
Why, I'm good on studying.
I don't even know what to say to that comment. I just don't even know what to say. All right, let's move on. If you'd like to come get the different kind, you're more than welcome to. All right, new sheet of paper. New sheet of paper. Set it up the same way. Your name in the upper left. This one's going to be called Creating Perpendicular Lines. We're going to call this one number 2.
Wow.
Stroop, if you want to open up that one behind you as well, that's fine. Go ahead and open that blind.
Yes. Turn it on.
Two in the corner?
No, you can do that. Stroop, go ahead and use the little bar there. Yep, that's good. Just keep turning it. That'll work. Perfect. All right. Here we go. To create perpendicular lines, you have to create a line through which you want another line to be perpendicular. The important part of setting up this particular construction is that your line initially goes through the center of your paper. So I'm just going to draw a line through the center of my paper, like so. And I'm going to label this with a point in the middle called A and a point at the end called B, like so. I will tell you that B plays no significant role other than for naming in this particular construction. A, however, will be a point that plays quite a significant role in this construction. So I'm going to explain in words what's going to happen here. We want to create a line perpendicular. That symbol right there means perpendicular. Create a line perpendicular to line AB through point A. So I'm going to create a line that is perpendicular through point A. If I had tried to draw this freehand, and I'm not going to, I have no guarantee that I won't be off by the slightest degree. So the point of a construction in this regard is that a construction in theory will give us a line that is perfectly perpendicular. All right? And of course, our constructions are only as good as our compasses. The better compass you have, the more accurate or precise your construction will be. These compasses are okay, but they might be a little off. All right, this is mostly compass work, whereas the last one was mostly ruler work. This one's mostly compass work. So the first thing I'm going to do is I'm going to take my compass and I'm going to set it up so that the inside point here is right around 5 centimeters. Okay, 5 centimeters. So on one side of your compass is centimeters, the other is inches. That's more a reference. We're not actually using that as a measurement, but that's more a reference so we can tell if it moves or not. Okay, so I want this inside point to be right about at 5 centimeters. I'm going to go ahead and place my compass on point A, like so. And this is where you have to be really careful. Where I place that 5 centimeters, I'm going to draw an arc that goes all the way around and intersects both sides. Now I have 2 intersection points that were created when I created this arc. This is a pretty big arc. It's more than a semicircle. I created a point here, and I'm going to call that point X. And because there's an intersection here, I've created a point. I'm going to call that point Y. And X and Y are the next 2 areas I'm going to work with. Okay. Next thing I want you to do is I want you to take your slider and I want to push it all the way out the end of your compass. Okay? That's going to be the easiest for us in this next step. What we're going to do is we're going to be working with this inside point, not the outside point. Inside point. Because if we work with the outside point, this will not work. Okay? So the inside point. I'm going to place my compass over point X. And I'm going to move my compass so that this inside point is almost below point A on my paper. And I'm going to draw an arc that if I were to draw a line straight down from A, would hit it. I'm going to go to the top now.
Doesn't really matter like how big it is, it just has to hit.
Yep, that's it. So it could be really small, it could be really big, but you'll notice I did 2 arcs. I did one here. And I did one here.
Oh. So like you draw a straight line straight through.
Okay, so I did that, and I did that. And now I'm going to flip over, and what do you think I'm going to do? I'm going to move my compass not to point to A, but to point Y. And I'm going to do the exact same thing. My arcs are going to be facing a little bit of a different direction. But now what I do is I'm going to use that inside hole again. And I'm going to do it so that they create 2 big curving X's at the top and bottom.
I can't do that.
Like that.
I didn't do anything here.
I can't do that, but I just
It's pretty awesome.
Okay.
Make a big smile.
Now, we created those 2 big X's because if 2 things intersect, we can put a point. So I can put a point here that I can call W. And I can put a point up here that I can call Z. And the final touch to this construction is that I line up Z, A, and W, or W-A-Z, WEZ, and I draw a line through all 3 points. And that's going to create 2 perfect perpendicular lines. So I put a little right angle symbol there in the middle. Yeah.
Can I get a compass?
Yes, you can.
You said up there is Z? Yeah.
Indeed it is. It's a Z.
label the x's on top and the bottom?
I called the top one Z and the bottom one W. You could have called them alpha and omega, beta and pi, ichthus and phi or psi or gamma.
No.
Hannah, Ugh. Hannah Montana, Miley Cyrus.
That's the world.
Two different pieces.
That's the ball first.
Perfectly screwed.
Yes.
We used to be. Casey, I'm beating you to speed today. You just draw Miley Cyrus.
I did, maybe.
Hey, Mr. Bornheimer, do you know how to fix a broken
There's
ruler?
an average screwed up person.
La 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 la.
That's what she sounds like. La, la, la. That's what she sounds like.
You should have put her on the wrecking ball.
That's actually Fergie.
Yeah.
That's Fergie that sings that.
All right, now we're getting out of control in here. Now we're getting out of control. All right. Last but not least, name in the upper left hand corner.
Come on, man.
Practice.
Second
Bro,
time.
practice. I got you there.
Two congruent angles. This is going to be construction number 3. Two congruent angles. That's what we're going to do today.
We should just do this for the rest of the year. Right? It's actually fun. I wouldn't have a
I
problem.
like this.
All right. First thing we're going to do is we're going to draw a line segment in the bottom left hand of your paper.
How far down do you want?
To give you kind of some perspective, I drew it right about there. So I left about a ruler's width on each edge. Now, my ruler is a little bit skinnier than some of yours, but that's a pretty good general rule of thumb. Like, Isaiah's ruler is a little bit thicker, more sturdy than mine is. Okay, so maybe he wouldn't leave quite a ruler's width on the edges. The next thing I'm going to do is I'm going to just draw, and I want this to be an acute angle. I'm just drawing one angle. And I'm going to label it W, X, Y. So this is angle W, X, Y. That's the angle that we need to copy so that we have two congruent angles. I kind of walked through this construction last week when I was giving you an idea of what it was that we were going to be doing. Okay? This is a real good even mix between ruler work and compass work. Angles have different components, and so we see those components get constructed in this next part. So the first thing that we need to understand is that this angle will be drawn on a line. Okay, so I'm going to start by drawing across my paper a little bit above halfway, a big line, like so. The part that's the trickiest is not the bottom part of the angle, because that could, in theory, be our line. It's how far up and how angled should I put the top part of the angle, and that's the part we have to figure out how to construct. Okay, so to do this, there's a lot of things that we can do right off the bat. I can put the two bottom points of my new angle on this line right from the get-go. So I'm going to go ahead and do that. And this one is going to be called A, and I'll put some point out here that I will call B. And now we just need to figure out where that line is going to go that goes through point A so that the angles are the same. And that's where the compass comes into play. All right, now the next steps may or may not be very similar for all of us, so pay close attention, please, because we're all going to have slightly different angles. What I want to do is you'll notice right off the bat that my slider is too far out. Maybe yours isn't, but mine is. So what I want to do is I want to move my slider so that the outside of my slider is just inside the end point of my angle, like that. Okay, so I've got my end on the vertex right here. And I've got my slider positioned so that the two holes are inside and will possibly intersect both parts of my angle, the top ray and the bottom ray.
Where do we have to line up the red thing?
Where the red thing, just inside these 2 points.
Not on the dot, but just.
No, just inside the 2 points. There does not need to be, it doesn't need to be lined up with any dot. Nope, that's a great question. Okay. Now, I'm going to leave my slider there. I'm going to put my pen in the outside hole, and I'm just going to make one arc. I am not going to change my slider at this point. I need to make sure it stays exactly the same. I drew an arc. Notice it went through both lines. I'm going to quickly, before my slider has any chance to move, take my compass up to point A, clamp it with my finger, like so, using the same hole, the outside one, draw a similar arc, and I'm going to make it a fair bit bigger. And I'm going to remove my compass. In theory, the distance between the arc and the vertex X will be the same distance between the arc and the vertex A. We are we are over halfway done with this construction. The next part is not too bad. Now, I'm going to label these intersection points. I'll label this one ichthus, and I'll make this one pi. And I know they're kind of hard to see.
Can we label them our own stuff though?
Yeah, you could.
Got you. I'm gonna do Lilo and Stitch.
Lilo and Stitch. You know, I actually do enjoy that movie a fair amount.
Yeah, that was a good one.
That was a good movie. A fair amount.
Watch that movie
All right.
1,000 and TV show. Oh, you're cool.
The way that we can find congruent angles, bring it back, Landon, Kennedy. The way we find congruent angles is we're going to measure the distance with the compass between ichthus and pi and transfer that distance up here to this arc. So I'm just going to put a generic point right here. I'm not going to label it yet. So right here. And I'm going to go ahead and put my compass over top of ichthus right here. So that new intersection point, not Y, ichthus. And I'm going to line my slider up so that it's over top of pi. Okay? Not W, but pi. That's important. They're close. Yours might not be as close.
Outside or inside?
Move the slider.
You're going to move the slider. Yep, very good. Move the slider so that it's over top of pi. You can use inside or outside hole so long as you use the same one when we transfer the measurement. So I'm using the inside hole because my angle's kind of small. So my one end's on ichthus. My slider's lined up with pi. To make sure everything is good, I'm going to draw a little arc and double check to make sure it's lined up. My arc goes through pi. That's good. So I know that my slider is the right measurement. I'm going to transfer it up to that intersection point. I use the inside hole. I'm going to draw my new arc so that this arc here, I'm going to put a star at the end of it, and this arc here are pretty much the same. Exactly. So then I put a point here. And the reason we do this is in geometry, there's a postulate that says you need 2 points to create a line. So the whole point was we had point A. No, the whole point of this, haha, that's a pun, but nonetheless. The whole point of this was that you had the vertex, but you needed that third point of that angle to create the congruent angle. That's why we did the construction. So now I can just take and through A and through my new point, draw a ray, call that new point C, and now I have angle A, oh no, Mr. Barnum. Angle, oh, I've got to label it the same way. So WXY, so angle CAB, cab.
Angle cab.
And I know that these angles are the same. So this angle, that angle
That's super cool.
are exactly the same. I can now say that angle CAB is congruent to angle WXY. I can say that because I constructed them to be identical. What you should also understand is that it doesn't matter if the angle is super short or the angle is super long. Okay? So whether this angle had stopped here, and that's all we'd had, and this angle, the lines extended out to the end of the paper, the length of the lines does not make a difference. It's the distance between the two rays that makes a difference. And the distance between these two rays is the same. So that's why they are two congruent angles. All right, that ends this recording on constructions 1 through 3.